Hi everyone, in this video I'll be going over Apply Your Learning question number 2 from the gas laws unit. Question number 2 states a 60-liter gas sample with an initial pressure of 680 millimeters of mercury is expanded to a volume of 120 liters, and it's asking what is the final pressure of this complex. So remember that a great strategy for solving gas law problems is to read through the problem and assign each value its appropriate variable so that you can compare those variables against the available equations to see which one would be best for this situation. So going back to the problem, we see that we're starting with a 60-liter gas sample. So that tells us that V1, or the initial volume, is 60 liters. It tells us that an initial pressure, or the initial pressure, is 680 millimeters of mercury. Millimeters of mercury is just a pressure unit. So we can call this P1. And it's expanded to a volume of 120 liters. So this is our second volume. We'll call this V2. And they're asking what is the final pressure of this complex. So they want to know what is P2. So looking at our variables, we have V1, P1, V2, and P2. So we can see that the best law for this problem would be Boyle's law, which states that pressure and volume are inversely related. So as pressure goes up, volume goes down, and as pressure goes down, volume goes up, given that nothing else is changing. So if we write out Boyle's law right here, we can fill in the variables with our values from the problem. So P1 is 680 millimeters of mercury. V1 is 60 liters, P2 is unknown, and V2 is 120 liters. And remember that the variables don't have too much importance as long as they're the same from start to finish. So as long as we're starting with millimeters of mercury and ending with millimeters of mercury, starting with liters and ending with liters, the equation still applies and it still works. So let's just simplify as we would with any other algebraic equation now. We have 680 times 60 on the left to get 40,800 equals 120 P2. Divide both sides by 120. And we find that P2 is equal to 340, and since it's pressure, we know that it has the same unit as our first pressure, which is millimeters of mercury. So the answer to question number 2 is 340 millimeters of mercury.